All right, today we're going to continue working on our unit on statistics, and today's lesson goes with digit 16.1. The title is Statistical Measures. In your table of contents, add the title of your lesson, Statistical Measures, and then on the next clean sheet of notebook paper, the title, Statistical Measures, and then our EQ for today. How can I use measures of center and measures of variability to analyze a set of data? Hit pause, set that up, your table of contents and your notes. When you're ready to move on, press play. All right, we're going to start with a few definitions. This may or may not be a review for you, but you need to copy these definitions down on your vocab page or in your notes. You don't need the example down here. I'll just kind of talk through it while you're copying the definition. Your first definition, what is the mean of a set of data? The mean of a set of data values is the sum of the data divided by the number of data values. So you add up all the numbers, then you count how many numbers are in your data set. So in this data set we have 1, 2, 3, 4, 5, 6, 7. So you divide the sum, whatever that is, by 7, and that gives you the mean. This is one of our measures of center. We're trying to figure out what's kind of the middle number there. All right, the next measure of center you need to know, copy this definition into your notes, is median. So hit pause and copy this into your notes. I'm going to talk through the example at the bottom, but you don't need to copy this down. We'll be working some in a minute. And so what is the median? We're finding the middle value. So there's kind of two different ways to do this depending on if there's an odd number of data values or an even number of data values. If there's an odd number of data values, that means that as you cross out numbers on the outside and work your way to the middle, there'll be one number in the middle, so that number is the median. And also, I didn't say this before, make sure you put the numbers in order from least to greatest when you're doing this. So in order from least to greatest, you start on the outside and you cross out kind of pairs of numbers, trying to find what is the middle number. So here for this odd number of values in the data set, we have just one number in the middle, which is 6. That's the median. When you have an even number of data values, after you've put them in order from least to greatest and you cross out, cross out, cross out, cross out, cross out, cross out, you get two numbers in the middle. What you do is you find the mean of those two numbers. So you add them together and divide by 2. So here we have 6 and we have 7 added together, divided by 2. That would be 6.5 as the median. All right, so looking at this graph here, we call this a dot plot. You may or may not have seen this before, but this is a dot plot, and each dot represents a time that this number occurs. So I'm going to first take the dot from the dot plot and make my list of data. Do this example with me in your notes. This is example 1. I want you to do it with me in your notes. So looking at my line graph here, I have 6 and I have 10. So I'm going to just make myself 6, 7, 8, 9 so that that'll help me know what these numbers are supposed to be. So I see one dot here, halfway between 5 and 6, that's 5.5. One dot at 6. 2 dots at 7, so I put 7 twice in my list. One dot at 8. One dot at 8.5. And then 2 dots at 10. Okay, so they've asked me to find the mean and the median. I'm going to start by finding the mean. It's not writing. Let's try one more time. Okay, start by finding the mean. I'm going to add up all the numbers, and I'm just taking the calculator to do this. 5.5 plus 6 plus 7 plus 7 plus 8 plus 8.5 plus 10 plus 10. So when I added up all the numbers in my data set, I got 62. And I have to divide by how many numbers are in my data set. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8. So 62 divided by 8, my mean is going to be 7.75. Okay. Now I need to find my median. To do that, I have them in order from least to greatest already. I'm just going to cross out and cross out, cross out and cross out, cross out and cross out. And I have two numbers in the middle, okay? So I have to just add those and divide by 2. 7 plus 8 is 15. Divided by 2, that's going to give me 7.5. So my median equals 7.5. Using the measures of center, what inferences can you make about how often the jewel geyser erupts? Well, we are looking to see that our measures of center are pretty close together, so we can predict that it is going to erupt every 7.5 to 7 3/4 minutes. Those measures of center are pretty close together, so we can expect around 7.5 minutes that it's going to erupt again. All right, hit pause and try this one on your own. Find the mean of the data set. When you're ready to check your answer, press play. So when we're finding our mean, it's not necessary for us to put them in order unless we're also going to be finding the median. We might as well just do that. So all I'm going to do is add up all the numbers in my data set, and I'm just punching them in my calculator. And so for my data set, when I add them together, I got 189. And then we divide by the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 9. And so 189 divided by 9 is 21. 21 is my mean. So that should be example 2 in your notes. All right, next definition. So we just talked about measures of center. Now we're going to look at measures of variability. Our first definition for the measures of variability is range. Copy this into your notes, and I'm going to talk about the example. You don't have to copy the example, just the definition. What is the range of a set of data? It is the difference between the greatest and the least value. So when you look at your data set, what is the biggest number, the maximum? What is the smallest number, the minimum? And you just subtract those. Now in this specific example, our maximum is 11. Our minimum is -5. So remember when we're subtracting a negative number, what happens when we have a double negative? We do plus plus, so we'd actually add them in this situation. Usually we're just subtracting, but if you do have a negative number, it might be different. All right, next definition is quartiles. How can I find the quartiles of a set of data? So it's kind of like finding the median, but like double. So the quartiles of a data set divide the data set into 4 parts with the same number of data values in each part. So we are finding each kind of quarter or quartile of the data set. The first thing you do is find the median. So the middle number, we already practiced that earlier. Once you find the median, that acts kind of like a wall, like a division between the bottom half of your data and the top half of your data. From there, you find the median of the bottom half of the number. So we'd cross out and cross out. So -1 would be the median of the bottom half. That's what we call the first quartile. Then we find the median of the top half of the data right here, and we call that the third quartile. Okay? So let's practice that. Just kidding. We're going to practice that after we do this last definition. Interquartile range. Copy this into your notes as well. The interquartile range, once you have found Q1 or the first quartile and Q3 or the third quartile like we did a second ago here, -1 and 8, you just subtract those. It's kind of like the range, but we're doing the range of the third quartile minus the first quartile. It is the spread of the middle 50% of the data, okay? So third quartile minus first quartile will give you the interquartile range. Hit pause if you haven't finished copying that definition, and then we're going to try an example. Okay, find the measures of variation for the set of data. The number of minutes spent bike riding are, and they've given us a list. So first I need to find the median. I know I have to put them in order from least to greatest. So I'm going to say 35, and I'm just going to mark them out as I copy. Please do this with me in your notes. I didn't say it. This is example 3. Do this with me in your notes. Okay, 35. My board's not writing. Let's see if I can fix that. 35. Next is going to be 80. Next is going to be, 100. Next is going to be 110. Next is 120. Next is 120. Next is 170. Last is 180. Cross. Okay, so the median is going to be the middle number. So I'm going to cross out from the outside going in. Cross. So I get two numbers. When I don't have one number in the middle, I add them and divide by 2, so that would be 230 divided by 2, which is 115. So the median is 115. I'm going to write that over here in my list. So you need to make this list of all these things on the left-hand side as well. All right, now, do you see how I've drawn this line between the two numbers? That is separating my bottom half of the data from my top half of the data. To find Q1, I'm going to find the median of the bottom half of my data. So 35 and 110. So I have these two numbers in the middle. Again, I add and divide by 2, so that would be 180 divided by 2 is 90. So Q1, or the first quartile, is 90. Okay, same thing with Q3, finding the median of the top half of my data. So 120 and 180 cross out. So here, I'm going to find 120 and 170 added together is 290, and then I just divide those by 2. 290 divided by 2 is 145. So Q3, or the third quartile, is 145. Now remember to find the IQR, the interquartile range. Our little formula is Q3, the third quartile, minus Q1, the first quartile. So I'm going to do 145 minus 90. And that should give me 55. Last is the range. We know for the range we just do the biggest number minus the smallest number. So 180 minus 35, what is that? 145? 145. Okay, now let me give you one of these to try on your own. All right. Hit pause. I want you to try and find all of these values on your own. You need to copy the list, put them in order from least to greatest, then find the median, Q1, Q3, IQR, and range. All right, the first thing we should do is put our numbers in order from least to greatest. Fast. 3, 5, 8, 10. What's next? 14, 16, 17, 20, 21, 21. Okay. Now, to find the median, cross out boom, 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 boom. So I have 2 in the middle. Add those and I get 30 divided by 2 is 15. 15 is the median, or sometimes you see that called the second quartile. Next, the first quartile. Boom, 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 boom. And we just have one number in the middle this time. So 8 is our Q1. All right, next. Boom, oops. Boom, 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 boom. So 20 is my Q3. I just have the one number in the middle. 20. All right, next, IQR. I subtract Q1 minus Q3. So 20 minus 8 is 12. Last, the range. I subtract the big value minus the smallest value. 21 minus 3 is 18. All right, the last definition you need to know is box plot. Hit pause and copy this definition into your notes, and then we'll talk about it. A box plot is a statistical graph that shows the distribution of data set by marking 5 boundary points where the data occur along the number line. So we see the 5 numbers that we were just talking about. The minimum is the smallest number, the maximum is the biggest number, Q1, the median, and Q3. And this makes up the box plot. Okay, so from looking at a box plot, or sometimes you'll see box and whisker plot, you will see these 5 values by looking at where the points are. So here we see the smallest number is -3. We see that the first quartile is 0, the median is 3, the third quartile is 5, and the maximum is about 7.5.